Hello bachcho, let's see this question. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happens to its energy eventually? It is a violation of law of conservation. Is it? First of all, we will divide some space. Okay, so we will divide some space. So what we will do is here we will draw our pendulum. First pendulum is released from somewhat this position. This will be the mean position of the pendulum. This will be the final position of the pendulum. Okay. So this is the initial position, mean, final. Okay. Here it is height h above the mean position. So we will talk now. We will have a discussion at initial position. There is no kinetic energy. Kinetic energy is zero because the bob is at rest, and potential energy is present, mgh, which is maximum. Okay, there is only potential energy. Now at mean position, as this travels from initial position to the mean position, potential energy goes on decreasing and kinetic energy goes on increasing. And as soon as it reaches the mean position, potential energy becomes zero and kinetic energy is half mv square, which is again maximum. And at final position, again kinetic energy goes on decreasing and potential energy increases. So potential energy becomes maximum, which is same mgh, and kinetic energy is zero. So I hope you understand that. I'll divide the area first. Okay. At initial, kinetic energy is zero because the bob is at rest over here. As soon as the bob travels the mean position, and from the mean position to the final position, first of all, in this phase is potential energy is decreasing and kinetic energy is increasing. Okay, and in this phase, kinetic energy is decreasing and potential energy is increasing. Okay, because it depends on mgh, h height decreases, potential energy decreases. So according to this, the energy changes which occur when we draw a pendulum bob from one side and allow it to oscillate. Okay, these are the energy changes that occur, and according to the law of conservation of energy, total energy remains constant. Here whole potential energy is converted, the whole potential energy at initial position is converted to the whole kinetic energy at mean position, and the whole kinetic energy at mean position is converted to the whole final energy, that whole potential energy at final position. Okay, now we'll come to the next side of the question, which says why does the bob eventually come to rest? Okay, so this is like our first, this will be our second. Now we will tackle why does the bob, it comes to rest due to air resistance. There is air resistance present which leads to it coming it to its rest. Okay, now the next says why does the bob eventually come to rest? What happens to its energy? Now what happens, it loses kinetic energy in order to overcome the friction caused by air resistance. Okay, to air resistance which leads to friction. Okay, and D is what happens to it eventually. Now what happens eventually? It decreases and it comes to rest. Eventually it comes to rest. Okay, now if we talk, is this a violation of uh, conservation, law of conservation of energy? Is it? Think about it. Is this a violation of conservation of energy? I feel not so. Why? I will tell you. Because kinetic energy or energy, any lost due to friction is gained by the surrounding or transferred to surrounding. So in some or the other form, energy is transformed from one form to another and it is given to the surrounding. There is no energy loss, there is no energy gain, it is only transformed. The kinetic energy gets transformed and get passed on to the surrounding. So this was our answer to this question. I hope you understood it. Thank you so much.